And well, it's all fine up to here. Now I'll close this and press new in the Dynamo to open up a new file. And now we want to get the specifications and do a couple more activities, such as the zooming, the color range, and also making some comments. So the first thing we're going to do is open this up and select the create zone with line file. Change the name from 12 to 13 dash assign parameter to zone. Change the name to this. Let me just type it out and then we can save it. Alright, now in the Dynamo, the first package that we're going to open up is the file path. Then I'll press the browse option and put in the create zone with line file here. Put the Dynamo on manual settings, and then I'll use right click to open up the geometry.import from SAT package. Open it up here. Let me just move it here and then we can connect it to the file path. Then hit run. And alright, that's all fine for now. Let me just select this and drag it over here. And alright, now I'll hit Ctrl S to save the Dynamo. And let's see what we have here in the list. It's solid. So I'll hide the package here. And then I'm going to use right click to look for the list.chop package and open it up here. Connect the list to the geometry and then we can hit run. Alright, so we have the length to put in here. I'll add a code block and name it 8. Connect that and run. And well, alright, let's see what we get in the list. Let's see how many solids we have here. 4, 5, 6, 7, 8, 9, 10. Alright, and as you can see clearly it has done the work of dividing these 8 by 8. And if we go through the list and select the items individually, we can see them in the plan here as well. And if you actually remember, we had 9 total surface parts here on the plan in the Revit file. We divided it into 9 parts. So I'll change the name of the code block to 9 and hit run. Now it's much better. And that's it, 9 in total. Now in order to do the coloring, first I'm going to use the list.count package and connect it here to the chop. Run, and we get 12 here. And I'm also going to add a code block here and specify in it from 0 to 1 with the amount of n. Connect that to the count and then we can hit run. After that, I'll use the color range package. Right click and look for it and then add it up here. Then I can connect the code block to the value of the color range. Press run and there we go, that's what we get from here. Then I'm gonna use right click to find the geometry color package. This one that says body geometry color. We find a link here, connect up the color, and then we can get the input for the geometry from the list. Hit run, and this is what it turns out like. Let's take a look around. Alright, after that, let me just take a look at the script here and let's change the number 9 to 8 in the code block. And there we go, now it's better. Let me just check one more time. Put in 10, 9. Alright. Change it to 5 this time and see what we get. Let's go with 12. Alright. Now the reasoning for the incident happening here is because 2 of these had been inserted on top of each other and it messed with our view. So if I add this one here and hide the list.chop, you can see the color range and how it's perfectly shown here. Now in the next part, I'm going to use the list.count package here, add it up, and connect it to list.chop. Run. Then I'll select the list and put it on level 2. Run. In order to see the number 9, I'll add a code block here and write in it from 1 to n, and then 1 here again. Then use Ctrl+C and Ctrl+V to copy this, connect the count to the code block up here, then run, and the count that we have from here, we can also connect to the code block up here. Run. There we go. Then I'll add another code block and put in x plus a double quotation with an underscore inside plus y. There we go. And then we can connect that to the code block here and this one up here as well. Press run, and this is in order to gather what we get from these two. And there we go. All right, now let me see. Let's take a look at the script to see what's what. All right, so I think there's a mistake here. I need to connect the count to the code block up here instead, because we don't want to get any empty lists here. And there we go, it's fixed now. Now what I'm going to use is the list.flatten package. Connect it to the last code block and hit run. And well, it's all fine up to here. We just need to move forward. And well, now I need to specify an element here. Let's say beam or column. Let me first search for the categories package here. And I'll have to go through the menu to find the structural framing and select it. There we go. The next package is the all elements of category in view. Let me just select this and copy the name of it, and also put it in the library search bar. And let me just select these and delete them and connect this one to the categories instead. Run, which gives us all of the beams here. Now what I'm going to do is go over to the library once again and type in geometry.deo, and well, let's see what we have. Select this one that says does intersect. And all right, now we are definitely going to need the intersection here between these elements for the next part. So let's leave the does intersect package for now, and instead I'm going to look for the get location package. First we're going to get the location of them, connect it here and run. There we go, and now we have the location of all of the beams in the list here. And if we take a look at the plan here in the Revit file, we can see how the location has been identified here, and we can see the effects. All right, now let's go forward, and let me just select these three and bring them down, then Ctrl+S to save the file. And the next step is searching in the library for curve dot point add parameter. Select the first package. Now we get the geometry from here, and we also want to put a point in between them. So add a code block and put in 0.5 here. Run, and there we go. Now the warning says ask to convert non-convertible types, and we can see the null results that we get in the list. So I'll create a code block, and let's give it a formula here. We'll put in x unequal to null. All right, let me just select the curve dot point and bring it lower, and then we'll have to change the formula for the code block. All right, and let's see if this one works now. And well, let's see. We'll have to do something else here because it doesn't give us any inputs. So I'll have to create a parameter for it. And well, maybe not. I think the parameter will be a tougher job to do, and we could fix this still. If I put in the comparison sign here instead, I think it'll be better. X and then null. Connect it here and run. And well, I think we had a couple truths down here in the list as well. Let's take a look at the list from the element.getLocation. Alright, so we don't have any nulls here. We have points and lines, and let's see if it accepts if we put in the line here instead of null and the code block instead. Press run, and seems not. So what I'm gonna do instead is delete the code block and do something else. I think we might be able to execute some sort of maneuver here. Alright, so let me just hit a couple of Ctrl Z's here to revert the actions in the Revit. Let's bring the code block here, connect it to the point, hit run, and alright, you can see the list gives us false. And alright, let's see what we get if we change the line to null. Run, and then let's see what we get in the list of the code block and if the results are working or not. I'm wondering why it's not working, so let's try something else. Let's look for by bool mask and open up the package, connect the mask to the code block and the list to the point and hit run. Let's see if this solves the problem. Alright, it seems not. So select and delete the code block, and instead of doing that, let's go up here and use right click to find the search and open up the list.contains package. Alright, it's not this one, remove it. Let me see if we can get it by typing in string search. It's not that one, string contains, and open up the package. And well, let's see what we can do here. Connect the geometry to the string here, and for the search for input that we have, I'll have to add a string and type in line inside. Let's see if we can solve this or not. Press run. Alright, and then let's look for the string from object package here. Add it to the script, connect it up, and press run. And the results that we get are true and also false. For example, for the 2099 item that we have here, it's set on false here, and if we look at it in the element.location, we can see its details here as well. And well, okay, it's fine up to here. So I'll select these two and bring them over here on the right. Select the geometry from up here and move it forwards. And then we have the filter by bool mask package, where we can connect the mask to the output that we get from the bool of the string.contains package. Then connect the list to here, run, and let's see what we get. Alright, this is the list for the filter by bool mask, and we can see the results. We get points from the list. So I'll connect the out to the curve here, select these and bring them over here and press run. Then I'll connect line to here. Now it's much better. So I'll continue the rest